Okay, so we'll take up a problem. Okay, so designing a high pass filter using FIR, and we have to use Windows method. So this is the ideal frequency response that is given. They have given n equal to 11. We have to use Anning window and we have to plot the magnitude response. Okay, so the response actually looks like this. So minus pi by 4 to minus pi, 0, pi, and pi by 4. So it's an high pass filter which says that from pi by 4 to pi it is 1. Okay, for the rest of the region it is 0. This is my HD of e power j omega. Okay, so what is the concept of Windows method? In Windows method, so the question, they'll be giving HD of e power j omega. The first step is you have to take the inverse Fourier transform. Inverse Fourier transform, you'll be getting HD of n. Okay, now for the range, okay, so from the range minus n minus 1 by 2 to n minus 1 by 2, first you will calculate the window coefficients. Whatever be the window, you have to calculate the coefficients. Okay, it is sufficient you use the range of 0 to n minus 1 by 2 because the filter will be symmetric. Okay, so using the property of symmetry, you will be calculating for 1/2 alone. Okay, second, you will use in the same range minus n minus 1 by 2 to n minus 1 by 2, you will calculate HD of n. These coefficients you calculate. Again, it is sufficient you use the range n minus 1 by 2 alone. Okay, so once you got these two coefficients, we need to just take the product of it. So W of n into HD of n. Okay, we need to take the product, that is your filter coefficients. This is your FIR filter coefficients. Okay, so that's how we are going to do this method. So for that, the first step is you need to find inverse Fourier transform, then calculate the Windows coefficients. Third step is calculate HD of n coefficients. Then fourth step is multiply the coefficients. That becomes your FIR filter. And the fifth step, if required in the question, in this question particularly they ask for magnitude response, you have to substitute z is equal to e power j omega and calculate the magnitude response for different values of omega. You have to calculate. Okay, so this is the sequence of steps that will be followed to solve this challenge. Okay, now the first step is inverse Fourier transform. So I will take up, so step 1, we have to calculate the inverse Fourier transform. Okay, so HD of n is equal to the formula is minus pi to pi HD of e power j omega n d omega. Okay, whereas for our case the range extends from minus pi by 4 to pi by 4, minus pi by 4 to minus pi. Okay, so sorry, I put the reverse, minus pi to minus pi by 4. HD of e power j omega is 1, e power j omega n d omega, plus pi by 4 to pi, it is again 1, e power j omega n d omega. Okay, now we have to integrate this. So if we integrate this, it is e power j omega n by j n, limits is minus pi to minus pi by 4. Similarly, e power j omega n by j n, limits is pi by 4 to pi. Okay, so going for the next step, so I'll take out the common outside. Okay, so jn is common, we'll take it out. So 1 by jn, so already in the formula you'll be having 1 by 2 pi, so Here I'll have a 1 by 2 pi, that I have dropped it, so we'll have a 1 by 2 pi. Okay, so now it is 1 by 2 pi jn, it is coming out, it is equivalent to, so if you substitute the limits, e power minus j pi by 4 n, okay, minus e power minus j pi n plus e power, okay, j pi n minus e power j pi by 4 n. Okay, so we know that what we know, e power j theta minus e power minus j theta by 2j is sine theta. Okay, so using that 1 by 2 pi jn, we'll group these two terms together first, so it is sine pi n, okay, sine pi n and into 2j, okay, sine pi n into 2j. Similarly, we'll group these two terms, will group it. I'll take a minus sign common outside, 2j into sine n pi by 4. Okay, now 2j gets cancelled. Okay, so it is 1 by n pi sine n pi minus sine n pi by 4. Okay, this is my hd of n, where n ranges from minus infinity to plus infinity.